Okay, this is Professor Eckhouse, and I'm going to talk to you today about linear functions and their graphs. So we're going to look at what a slope is, and we're going to calculate slope given 2 points, and then we're going to graph a linear function using the slope and the intercept, the y-intercept. All right, so some things to start with here. One, we really need to think about what slope of a line is. So I want you to pause the video and see how many ways you can come up with to define the slope of a line. All right, so hopefully you paused the video and you've at least thought about it. So some things that some people have said are the steepness and direction of a line. Right, how steep it is. It's a ratio, right? It is a ratio, which is a proportion. So it's proportional. It's a ratio of up versus over, right? And some people, like construction people, will use the word pitch, the pitch of a roof, how steep it is. It's how, you can look at how steep a hike is when you go up the side of a mountain, that kind of thing. So it's also called the rate of change. The rate of change. How much it changes, how much something goes up as you move forward, for instance. So we are going to always use the units from the graph. You probably didn't think about that one, but it's just something I wanted to throw in there. Use the units from the graph. Okay, so if the up is miles and the over is hours, then you would get miles per hour, right? We'll talk about that more. All right, so let's look at an example here of a slope of a line. So slope is going to be how much it goes up with the perspective or with respect to how much it goes over. Okay, so the best way to do this is you want to pick a point on the line that's exact. So I've got a point right there, 1, 0. Okay, so this is 1, 0. And then find another point that it goes to, like say that one. And I'm going to say, how much is it going up with respect to how much is it going over? All right, so the up and the over. The up is 2, so we're going to say up 2. Over is going to be, and I'm going to say right instead of just over. I'm going to say right. Oh, I think I got that wrong. For this one, I picked a different point when I was playing with this. Up 4, I go 1, 2, 3, 4, and I go right 2. Okay? But I could also pick different points, right? So this is what I did in my notes. I didn't notice. But I'm going to go, there's another point right there where I can just go up 2 and over 1. So I'm going to go, I could also go up 2 and right 1, right? So let's try to find another one. What if I started at 1, 0 and I went to here? I'd go 1, 2, 3, 4, 5, 6. So that would be up 6. And then I would go right how many? 1, 2, 3. Right 3. In every single case, 4 over 2, 2 over 1, 6 over 3. These all reduce to 2 over 1 or just 2. Okay, that is a ratio, 2 over 1. And they are all the same. It doesn't matter where you look on the line. It doesn't matter if you go backwards and look downwards from that point. And we'll look more at that soon, okay? So slope is just a ratio of two numbers, and it doesn't matter what points you pick, you will always get the same ratio. All right, so calculating slope. The slope or rate of change of a function can be calculated using the following formula. So remember, we've used some different words, slope, rate of change. Right? It's going to be a change in what we call output, right? That's the rise. So don't forget the output is this one here, output. And the input is this one. This is X and this is Y. Okay? This is Y. So output, input. So let's look at that. M is the change in the output, which we often call the rise. And the rise can be downward, right? It could be negative. Compared to the change in the input, which we call the run. right? So then we call the change in the output change in y. So we say this, this symbol right here, we say delta, and you really are supposed to make one side thicker than the other, but so that side thicker, delta, but it's just a triangle. So delta means change, or change in y over change in x, okay? So that means what we would do if we didn't have it graphed, if we did not have it graphed, is we would say the change in y is going to be y2 minus y1 over the change in x, which is x2 minus x1. So what are x1 and x2 and all that? Well, we're going to have 2 points. So we're going to have x1, y1 as a point. So this is going to be point 1. And then we'll have a point 2, and I'm going to move this so it doesn't look like the point 1 goes on top. Let's come down. Let's come over here. I'll come right here. Point 1 is x1, y1, and point 2 is going to be x2, y2. So point 2 is x2, y. I'm just having a hard time writing today. x2, y2. Okay, x2, y2. I'm going to erase this little 2 while you write it down. I will fix it. All right. So different points have different numbers as subscripts, so we can keep track of which is which. All right. So what does a positive slope look like? What does a positive slope look like? Let's think about that. A positive slope is going to be anything where if you're moving left to right, so read left to right, it's going to look like that, or that, or that, right? It's going to go upward. A negative slope is going to look like going in this direction, right? Well, that wasn't very straight. Let me try that again. Going this direction, or like that. Or, you know, it can be even just a little bit more than horizontal, or it can be really steep, but it's going downward. So if I was moving left to right, think about, am I going uphill or downhill? So you always want to be moving left to right, from smallest to biggest on the x-axis, and think about, am I going up or down? All right, so an increasing function has a positive slope. Okay, a decreasing function has a negative slope, and a constant function has a slope of 0. Okay? All right, so make sure you understand increasing has positive, decreasing has negative, and constant has 0. Have that in your notes somewhere with a big star next to it. All right, so this one is just like question 1 on the homework. So I wanted you to see it here and practice it. So here's what we're going to do. We're going to name our 2 points first. Okay, so let's name our 2 points. So we're going to say x1, y1 is going to be, we'll call this one number 1 right here, is going to be 3, negative 2. And x2, y2 is going to be that one. So we'll call that one x2, y2 is 8, 1. Some of the biggest mistakes I see is people not taking the time to just do this. Okay, so just do this. All right, so now what is slope? So let's write it down. Slope is m, so we call slope m, as you saw right up here in the definition, m. So m is y2 minus y1 over x2 minus x1. All right? All right, so y2 is going to be the 1. Okay, the 1. And then we're going to say minus, and then the y1 is the negative 2. And I'm going to color code for you so you can see exactly what's going on here a little bit better, hopefully. And then we've got the x2, which is 8, minus the the x1, and the x1 is going to be 3. All right, so make sure you keep track of that. The biggest mistakes I see here is people just plugging in the wrong ones. All right, so 1 minus negative 2 is 3, 8 minus 3 is 5, so our slope is 3 over 5, or you might see it in decimal form sometimes, 0.6. Okay, so you need to make sure you know how to do problems that look like that. If those are hard for you, remember to just ask for a new version and try it over and over again. All right, so there's a homework question that looks like this. Question 2, the population of a city increased from 23,400 to 27,800 between 2 years, 2008, 2012. Find the change of population per year. The change of population per year is going to be, let's put this in terms of x and y, okay? X and y. So I'm going to say x is the input, of course, and y is the output. Okay, so for our first point is going to be this number of people this year. Okay, so we've got our input, x, is always the year. Believe it or not, it's always time. Okay, x is always time. So the output then is, and think to yourself, what does what depend on? Does the time depend on how many people are there? No, time doesn't depend on anything, so it's the input. All right, the second point is going to be this one, this many people in this year. So 2012, we had 27,800 people. All right, so the change in population per year, this right here is what we're looking for. That is just m, all right? So m is going to be y2 minus y1 over x2 minus x1. All right, so I'm going to stop color coding because, well, no, I'll just keep doing it. So 27,800 is y2, and then we need y1. y1 is 23,400. All right, so this is all over the years 2012 minus 2008. Okay. All right, so we get the change in people is 4,400 people. So remember the top is people per 4, what's the bottom? What's the unit on the bottom? 4 years, right? 4 years have passed. All right, so now if I put this in my calculator or just think about it, it's 1,100 people. So what I said about units before, you got to think about the units. People per year, right? So change in population per year, the question often helps you to figure out what goes on top and what goes on the bottom. So that'll give you a hand. There are 2 more videos with word problems at the end of this section of the text. So it's at the very beginning of 5.1, that first page. So towards the end of that first page, there's 2 videos. So watch those if word problems are hard for you. All right, slope-intercept form of a line. Slope-intercept form, very important. So we would say y equals mx plus b, or of course f of x equals mx plus b, because x is the input, and that is function notation. Remember, this is function notation. So we're just saying, what is the function when I plug in x? I'm also saying that x is the input, all right? So this is function notation. All right, so what is m? M is the slope, right? And b, what is b? B is the y-intercept, right? What does that mean? Where it crosses the y-axis. So now, this can be reported as a point, right? Which is going to be 0 and whatever the y is, or just a number. So you have to be careful, read the question carefully. There's different ways to report that. All right, so let's think about what the equation would be for this one. Right, so we've got y equals mx plus b. So m equals and b equals. Let's find them both. All right, so we might as well find b first, and it's telling us right here what the y-intercept is, right? It says the y-intercept is 0, 1. So that means that b is 1. All right, so when we use b, it could be reported as given to us as a point or a number, but b itself is always just a number, okay? So it can be given in the problem as a point or a number, but b is just a number in the equation when we go to make the equation. All right, so m is the slope, so I'm going to start at that point right there, and then I'm going to go find another point. Well, I see one right there. I could pick any of them. They're all going to work. So the rise is 1, and the run is 2 over 2. So rise over 1, run. And so let me actually move that over so we can make ourselves a little equation. Okay, so the equation is change in y over change in x. And I just counted up and I counted over. All right, so what is my new equation then? My equation of this line is 1/2 times x plus 1. Okay, so the 1/2 goes here for the m, and the 1 goes here for the b. All right, so you just need to get used to being able to do that. Do all linear functions have a y-intercept? So I just want you to think about it. Any line, can you think of any lines that are a function that might not have a y-intercept? And when we use the word all, it has to be all, right? Even one is not true, then we can't say all. And the answer to that is yes. Yes, all. Because you may have thought, what about a vertical line, right? It doesn't cross the y-axis, but it's not a function. A vertical line is not a function, right? All right, so what about y equals 3x? It has no y-intercept listed, right? Where's b? We've got y equals mx plus b. There's no b. So what does that mean? Well, that just means here that b is 0. That means it crosses through right here. Okay, so if we were going to draw this line, I'm just going to do some counting. I'm going to go up 3. So in this case, right, m equals 3. So I'm going to go up 3, 1, 2, 3, and over 1 and put my point there. And so my line would look like that. Okay, so there's one example. It looks like it doesn't have a y-intercept. It does. The y-intercept is 0. So again, I just said it. What about a vertical line? A vertical line is not a function. It's not a function. It doesn't pass the vertical line test, right? It doesn't pass the vertical line test. So, all right, how to graph a line in slope-intercept form. Identify the y-intercept and the slope. Plot the y-intercept first, and then go up and over to determine at least one more point. 2 more makes it so you're safe in case you messed one of them up. Okay, so sketch the line that passes through the points. All right, so try those steps and try graphing this equation. All right, so I'm going to do this one with you. So the first thing we need to do is plot the y-intercept. But first, actually, let's say, before we do that, until you get really good at this, I'd like you to do this first. And I'd like you to say m equals and b equals. Okay, so m equals -1/3 and b equals 2. All right, so now what are you going to do with that information? I would like you to start with the b and then do the slope. Because remember, this is just rise over run. Well, one of them has to be negative. Think about that. What are we going to do with that? So you can make the top or the bottom negative, right? So it can be, the negative could be on the top or the bottom. So let's start with a 2. So b equals 2. So that means the y-intercept is 2, 0, 2. Okay, the y-intercept is 0, 2. All right, so now what is the slope? -1/3. Well, all right, so let's work down here. So we've got -1/3, or we can say 1 over -3. The top being the rise and the bottom being the run. All right, well, let's just work with this one first, okay? All right, so we're going to say -1. So that is the rise. So I'm going to go down 1, and then I'm going to go right 3 because it's positive. All right, so I'm going to go down 1 and right 3, and I end up right there. Well, that looks negative to me. It's going downward from left to right. Let's use the other one and see what happens. I'm actually going to change the color of this one to, let's do orange. All right, so that one is going to be, right here, is going to be up, and this is going to be left. So let's start at our original point. Let's make the original one red. All right, so we're going to go left, I didn't finish my word, left and up. All right, so start with up. Doesn't really, I guess, matter, but I'm going to start with up. So I'm going to go up 1 and the left 1, 2, 3 to right there. Does that look like it's still in line? Yes, it is. Okay, so you can go either way. with the negatives or with the positives, as long as you think through what positive and negative means, up, down, left, right. All right. Why don't you try, oh, and sorry, you would draw a line. Okay, so my lines are so terrible, I'm just going to leave it at that. You draw a line. Just going to move on. All right, so graph g of x equals 3/4 x minus 3. All right, so let's look at g of x equals 3/4 x minus 3. And I'm just going to write g of x equals mx plus b right underneath it. And you can do that too if you want to. So my m is going to be 3/4 and my b is -3. Be careful, there's a negative there. Okay, so the equation is a plus, and if there's a minus, that means that b is negative. All right, so remember that this is step 1 and this is step 2. So first start with plotting your -3, so right here, that's going to be at 0, -3. All right, now my slope is 3/4, so that is going to be up 3, right 4. So I'm going to go 1, 2, 3, 1, 2, 3, 4, and then I'll erase all those others. Okay. All right, so that is where I end up. And notice I could go down 3 and left. So I could go 1, 2, 3, 1, 2, 3, 4, and you end up on the line because I went backwards with both of them. Negative, negative makes a positive. So you don't have to do that if you don't want to, but I just wanted to point that out. All right, I'll try to make a line. There we go. Ta-da! All right, next one. Graph this one. So definitely pause the video on this one. I think I've covered all the negatives, so give this one a try and see what you can do with it. All right, we've got y equals mx plus b, where m equals and b equals, so hopefully you got that. M in this case is -3 and b is 5. So again, start with this one, plot the point, and then do the slope. Okay, so the point is 5, 1, 2, 3, 4, 5 right there. All right, and the slope is -3, so this thing should go down that way, right? So make sure you think about that first before you do anything else. All right, so m is -3, which means -3 over 1, or which means 3 over -1. Either one, it's the same. It's the same thing. All right, so I'm going to go, this means that this is going to be up, down. So this is up, down, right? Just like up here, we chose up 3 and right. So, but this is not up, it's going to be down because it's negative. Okay, and this one's going to be up. What about this one? This one's going to be right 1, and this one's going to be left 1. Okay, so down 3, up 3. All right, so I'm going to go 1, 2, 3. So that's my up 3, and so I need to go left 1, and I end up right there. Is that going to give me the negative slope that I thought about? Stop right there and make sure you did it right. So understand increasing, decreasing, negative slope, positive slope, and understand which way it needs to go so you can catch your mistakes. These are easy to just make little mistakes on. And then it's totally wrong. All right, the next one we're going to go down 3. I'm going to try this one and then over 1. So I counted down 3 and over 1, and I am left with this line that looks about like that, sort of. Imagine it goes through the lines, or through the points. All right, so now there's a problem in the text in the middle of this second section of the module. So I would try those problems. So it's a good try it problem. All right, so give the equation of the line with a slope of 5 and a y-intercept of -2, and then graph it. All right, so a slope of 5 and a y-intercept of -2. Let's write that down. So we've got a slope of 5 and a y-intercept of -2. Now this could be reported, they could give you this as 0, -2, right? Or just a y-intercept of -2. Either one, so be prepared for that. All right, so our line is y equals mx plus b, and m is 5, so I'm going to say y equals, and I put the 5 in right here, x, plus, and the b is negative 2. So let's write this properly. Y equals 5x minus 2. So that is your final. It does not say in function notation. If it did, I'd have to say f of x equals. Okay, so be careful, read the problem carefully. All right, so now we're going to graph it. So remember step 1. Step 1 is to graph the y-intercept. So that is going to be at negative 2 right there. And the slope is 5. That means 5 over 1. So remember that means 5 over 1. So up, and this is right. Okay, so make sure you think about that before you do it. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. And then I could also go down 5, 1, 2, 3, 4, 5, and left 1. As long as you do that, do both, you'll be on the line. So double check that you got a good line, everything's on there, you didn't mess anything up, and imagine I can draw a straight line. All right, let's try that again. All right, found the values. Oh, this is a little different. Find the values of m and b from the graph, then write the equation. So you're going to see some problems like this in the homework or knowledge text. You need to be able to do these. So the first thing you want to do is find m and b. Okay, so m and b. Which one should you find first? It doesn't really matter, but as long as you have to find a point, because you're going to have to find the slope, I'm going to go ahead and say that b, there it is right there. So b is 0, 5. So this is the point 0, 5. So b is 5. All right, so the slope, I'm going to go find another point. I see one right there, and I'm going to go down 2. Okay, so down 2, and then 1, 2, 3, 4, right 4. And this is going to reduce to negative 1/2. Okay, so we get y equals mx plus b. Y equals negative 1/2 is the m, plus the b is a positive 5. Okay, so there's our final equation of that line right there. Okay, one more. Write the equation of the line with a slope of negative 2 and a y-intercept of 0, 8. Okay, so we have the slope, and the y-intercept is given as a point. And remember, it can be either one, so be flexible. All right, so slope means that m is negative 2, and the y-intercept means that b is, well, it's at 0, 8. So 0, 8, think about this. It's right there. So that means b is 8. Okay. All right, so it has a slope of negative 2, which means that it could be negative 2 over 1, or it can be 2 over negative 1. All right, so I'm going to use this one because I don't have much room left at the top there. So I'm going to use that one. So I can go down to 1, 2. That's the rise is down, right? And then right. So down 2, right 1. Down 2 more, right 1. And I've got myself a line. Okay. Again, you only really need 2 points, but I always do one more just to kind of make sure I've really done a good job of putting the points in the right places. All right, so when you do this homework in Lumen, do not do your work in Lumen. Do your work on paper, right? Do your work on paper and then put your answer in Lumen. All right, thanks for watching.